Just as an introduction, I'm Josh Kaysen, sales manager here at Airflow. I know many of you from dealing with you in the sales world. We're gonna have some fun talking about rooftop units today. Basically, Angeline came to me and asked, what problems do we see with rooftops? What challenges do we see when we're bidding them? Do engineers always have the right match with the rooftop that's selected versus what the intended purpose of it is, or what type of application we're in? So we're gonna spend some time going through that. Fair warning, I'm going to have some information that's gonna be somewhat proprietary with Tempmaster, our line of rooftops. For the most part, everything that we're gonna discuss is pretty universal in the rooftop arena. We are going to see some things that are specific though to Tempmaster as far as their components and some of their systems. So to start out here, thank you. In our introduction emails that we said about this class, you see this Venn diagram. What we're trying to do is really spend some time marrying up what a client desires from a system standpoint. We have highly energy efficient systems over here. Some of these are Cadillacs that, maybe the budget doesn't fit. We have, the wish list of the things that the client typically wants here. A lot of these things come down to componentry of a system or what the scope of the budget is. And what we often find is that with the flexibility that we have with rooftop units is we see a good marriage in the middle here, meeting up with some of the intents of the system design as well as what a budget looks like. Oh, okay. Here you can see this is some Tempmaster information that they provided to us. You can see that rooftops and splits account for almost 60% of the marketplace that we typically see. Is this changing? This data is, I think, from 2023. I think so. We see a small amount of water source heat pumps and VRF in our market, not a ton of it. Healthcare, we see a lot of chiller, air handlers, boiler plants, that type of thing. But when you're looking at commercial projects, some industrial, warehousing, all of that, often we see rooftops in that space, strip malls of that nature. What we do see more and more of, at least from my perspective, is that, on smaller healthcare projects, rooftops can be a great solution for some of those things. Industrial spacing, there's flexibility. Schools, we see a lot of rooftops if they don't already have a chiller plant on site or a boiler plant. Going a little bit deeper into that first Venn diagram, this is a second take on it. You can kind of see here that we're gonna have, all these options on the side here are customizable. Some of them are available from 2.5 tons all the way up to 150. Some of them are only gonna be available on larger size units. We're gonna dive into that a little bit and really kind of walk our way through where we might see some of these things, where we might not. On this side, we have, just basically your off-the-shelf rooftop that you're going to find at a distribution wholesaler. Very plain Jane, not customizable. There are some add-ons that we can do afterwards if you do need something in a hurry. Stocked off-the-shelf units are always good for what their purpose is. So next one here. This unfortunately didn't come through. Is there another? Oh, there we go. That's fine, just leave it here for a second, we'll do it. So here you just see, basically within the rooftop market, that commodity product type that we were kind of talking about on the right side, up to 15 tons makes up a very large chunk of the market. You know, very rarely are we seeing anything over 25 tons. I guess not very rarely, but it is a much smaller piece of the pie. When we're looking at projects, one of the nice things about using rooftops, especially for a school, you may have a space that requires, you know, a 25-ton unit in one area. But, you know, with the small footprint of some of these other units, you can pick and choose your spots to be able to drop one in there and use some of these smaller units in coordination with larger unit. Okay. Guess this was a working slide. I didn't realize that. Okay, so the only other marketing pieces we put out for this kind of said, you know, what is the puzzle of putting a rooftop unit together? You know, we look at this typically as, you know, varying levels of add-ons that we can put to a rooftop to build it. But these are the main considerations that we're typically looking at a minimum of what we're gonna need when we're going through it. Obviously, you have humidity control. That's always an issue in space, especially in our climate when we're talking about shoulder season. Economizer options. It's pretty simplistic, but you'll see that as we get into it, I think there's misapplication of these quite often. We do see a lot of, you know, there are ASHRAE guidelines that we need to follow and code guidelines that we need to follow on economizers that help drive the system that you're gonna have. We're gonna do a brief overview of low pressure and high pressure systems. Basically, we're gonna be looking at, okay, so we have a rooftop, you know, what are we trying to do? Are we doing zone control? If we're doing zone control, do we have options to do a low pressure ductwork system? If we're doing VAV, we're likely gonna be in high pressure ductwork or medium pressure ductwork over 2 inches, where cost gets a little bit on the higher side. We need some add-ons on the fans in the units, that type of thing. So we'll go through that to a small end. Control strategies. This is just kind of an overview tied with the pressure or the system options that we have in the previous category. Just going through that and really focusing on what your space might need and how you can control that. Final, we're gonna dive into, this is gonna be the proprietary portion of the presentation. We're going to spend some time just looking at different tiers of rooftops from the Tempmaster perspective, explain what some of the options and accessories are that are there. And really, you know, at that point, I really want to make sure that online people are coming up with questions about things. What do you see in your selections? You know, you'll see things that probably would never dream of putting in a rooftop unit when we get into some of our higher end things. You may see some things that you think should be included all the time. So we'll dive into that a little bit. And for that, fair warning, Tempmaster doesn't have everything. There are other manufacturers that specialize in this space and have some better options and better solutions for things. We recognize that, and you'll see that in some of the other puzzle pieces that we have here. So where do we start? Basically, just overview of what we're talking about. You know, packaged units, we're looking at just, you know, typically a wide range, 2 to 150 tons. Some manufacturers might go a little bit bigger. That's about where we are. Somewhat customizable, semi-custom, you know, some of the units are, like we said before, off the shelf. They're gonna be what you see is what you get. So we're gonna expand on this a little bit as we go on. Obviously, DOAS is a rooftop unit. We're not gonna spend a lot of time going into DOAS systems. They have great functionality and we're seeing more and more of them, especially when you're coupling them with more sustainable solutions that we have, where you are just basically introducing ambient air into the space for fresh air. They do have, you know, I do see these applied all the time in healthcare as well, where maybe we're treating critical spaces with just a DOAS unit separate from the rest of the system. Again, with that comes a cost though, right? So we definitely have a benefit to it, but with that is a cost. So are there ways that we can do the same things with the DOAS with a rooftop unit? Maybe there are. Maybe we'll find those solutions as we go on. Again, when we talk about off the shelf units, we also have semi-custom and then even more customizable. Everything comes down to the cost. And the general rule of thumb is the higher the tonnage, the more options you're gonna have. So, you know, with Tempmaster, we kind of break it at, you know, up to 12.5 tons is where our kind of off the shelf units are gonna fall into range. 15 to 25, 30 is that semi-customizable range where we'll have a little bit more and we'll dive into those selections. Anything above 25 tons, you know, we can really get into the high functionality, whether it's, you know, high filtration, energy recovery, all those other things that we see. Not that they're all exclusive to the fully custom units, but they are typically used in those applications. Any questions so far? So we're gonna spend some time going into the first puzzle piece, and that is about tackling humidity. So when we're talking about common solutions, smaller tonnage units, typically we're gonna see a staged unit. A lot of times we'll see a single stage. I know for us, we really struggle with most everything underneath 7.5 tons. 7.5 tons and under is a single stage unless you're in a 6-ton unit where we can go 2-stage. Up to 12.5, we'll mix and match some dual compressors in there. Digital stroke compressors, some manufacturers have this, some do not. From our standpoint, we're still working those into our product offering on the smaller tonnage units. We do have those available at everything over 12.5. I don't know if everybody's familiar, but we have a little kind of ace in the hole with Raywall APR valve. We'll watch a little video that kind of describes that in a little more detail and how it works. And then also we can typically manage some humidity with utilization of bypass with a variable volume, even though we have a constant, the compressor's running at a constant speed. Large tonnage, typically you're gonna see these are all gonna be staged, whether it's 2.4, up to 8 sometimes. All depends on the compressor sizes that are built together in order to get the tonnage for the total unit. We'll go into a little bit. Hot gas reheat can also be a common solution in that smaller tonnage. It is expensive at a smaller tonnage though. It comes with a premium. Hot gas bypass has a lot of similarities to the Raywall valve. It is something that we're not seeing as much of anymore. Some of the units have that. We'll again watch a little bit of a video with that. Again, then variable volume with staged cooling is a very simplistic way of doing it. We'll vary the fan speed, bring compressors on as the cooling load to meet set point. The whole point about tackling humidity is we want to keep that evaporator coil engaged as long as we can in order to bring out that moisture from the air. And then even with a VAV system, sometimes you'll see the decoupled reheat at a VAV box. So you can have more individual humidity control if required. Digital scroll compressors, like I said, is one of these. Obviously, we're modulating the capacity of the refrigerant as it's going through, leads to better capacity control. Here, I'm not going to get into the intricacies of how digital scroll versus scroll compressor versus other compressors, but know that essentially it's the similarity of having a drive on your fan. You're just being able to turn down the compressor and have part load on a single compressor. So the APR valve, like I said, this is something that we rely on quite a bit. We'll see this in instances where maybe we have a 10-ton unit with 2 stages and we want to manage our humidity. We'll use an APR valve on one of the stages, on the first stage. So in essence, what we've done is we've allowed that this valve, and you'll see how it works here in a second. We'll be able to have some variability through that first stage until we get to the second stage. Then we can bring that on and couple that with, if we get to, say, if we have 2 5-ton compressors and we have an APR valve on the first stage, we can also run that second stage at full capacity and then modulate up with the APR valve on the other one. So it allows us to basically replicate some of the things that we could do with a digital scroll compressor through a different process.
And if you have multiple refrigeration circuits, you can have an APR on each individual circuit, so it gives you even more range.
Yes.
And the beauty is that it's very, very, very little controls required. It's just a mechanical device that's sensing for refrigerant temperature. So it kind of works on its own without little control integration, and is phenomenal for those jobs that somebody oversized a piece of equipment and
Yes,
they're trying to
and especially in Wisconsin with design days being what they are, we may only see full load on a piece of equipment maybe 5 to 10 days a year.
Yeah.
But come April and May, we're going to need cooling in that space. We're going to have we're going to have cool, moist air outside. So we're going to want to be in economizer mode. Well, we're going to be bringing in cool air that's very wet. So,
and if you use it with a combination thermostat, humidistat, you can force the compressors to run longer. The unit will continue to run and you'll get some dehumidification.
yes.
with less overcooling. You'll still get some, but it'll drastically reduce your overcooling.
One of the things that, when I've done research for this and for projects and other things, kind of the rule of thumb is that 10 to 15 minutes of having your evaporator coil engaged is the minimum that you're going to need before you start to get dehumidification. So if you're running into a system where maybe you have a 7.5-ton system, but your load's, only 2 tons of cooling required at the time, you're going to just hammer that thing on and off because you're going to satisfy temperature so quickly. So having a method to do that on a smaller unit like that is something that's very, very much in need. Why don't you, Sienna's going to play the video here for the APR valve. So we did have a couple questions that came in on the chat. The first one was, how small of a unit can we install this on? I don't know the exact, 1.5 tons. Thanks, Dave, for looking that up. We can go down to 1.5 tons.
All the way up to 10 ton.
And all the way up to 10 ton. So there is a nice range there. There's also a question about whether or not this is just an aftermarket product. It can be applied aftermarket. We've done that quite a bit when we've run into problems with humidity control. It is a relatively simple fix. We do have a tech here at Airflow that won't do the actual piping for you, but he will work with you to get the setup right, work with the controls of a unit and be able to help you out with getting that up and running.
There is a chart both for split systems as well as package systems that gives you the specific information on what the turn down ratio is. Now you said max is 10 ton, but
As an individual
as an individual
Single unit, yep.
circuit, okay.
circuit, yep, for full modulation, you could put multiples on. And these can be added at the factory too, they don't have.
Yes, and that was the other point I made. Tempmaster will install this. It does add some lead time to a unit. But as you'll see when we get into our selections, we're gonna show you, it's not a standard. It's something that's customizable. We have a separate facility that units are shipped to for any modifications that are made. Again, here is just that representation that you saw in the video. Again, the device is very small. That's obviously not the scale, but it easily fits within the piping of a unit. And we're able to basically insert it in place if need be after, or like I said, it can be factory installed. So again, just summarizing where we see these, obviously oversized systems where we can address short cycling. High latent loads on small systems is another good opportunity there, just so we don't satisfy temperatures quickly because we're actually raising that discharge air temperature significantly through the system. And it also allows us to be a little bit more precise on temperature control than we would be with a single stage or a dual stage unit. Okay. Everybody here, or not everybody, but most people are familiar with hot gas reheat. Again, this is just another application that we see of how to handle humidity. We're gonna go through a video here of showing, I don't wanna go through this slide in its entirety, but typically we'll have staged hot gas reheat or modulating. Both of them are available in most product lines that are out there. It's always called something different. We call it Magna Dry, Lennox calls it something different, Carrier Train, they all call it something different. It's hot gas reheat. Basically, you're pulling some of the hot gas out of the system, pushing it into a secondary coil that's downstream of the cooling coil. So you're going to do the same thing where you have cold air, or you have the cold air coming off of the coil, condensing on that coil, and then we're reheating it up to a temperature where it's going to, basically we can overcool with that coil to bring out more moisture and then bring it up to a reasonable temperature to supply to the space. Hot gas bypass, similar to what an APR valve does. It provides an artificial load on the evaporator. We'll see here in a second how that actually works. This is kind of a dying system. We don't see it very often anymore, but I did want to mention it. So if you could play that second one, Sienna. through before. If anybody wants those videos sent to them, we can accommodate that. After, just send a text through or send something through the chat and we'll get that to you. Economizers. When we talk about this, everybody's, obviously we need to meet code. We need to bring fresh air. We want to get free cooling. I see this misused sometimes. People say, well, we would like to have powered exhaust on a system. When do you want to apply that? We're going to go through that a little bit. Very simply, how a barometric relief works in a system. Basically, what we're going to do, and this is more common with systems where we're going to have a variable volume airflow coming through, which is most systems these days. As the unit approaches 100% outside air, we're going to pressurize the space. Typically, you're not going to have a return duct on a unit. Maybe it's something that's in air or a short run of return duct. You're going to build pressure in the space and you're going to need to relieve that. It just cycles through the system, through the return, and barometric relief damper will open. It is typically 1/10 of an inch in order to really move the damper. Where we see this, and it can also be replaced by a motorized damper in some instances, would require a signal to do that. One of the things that we'll see with regards to a barometric system is ASHRAE code doesn't allow us to go over anything taller than 3 stories for barometric relief. The reason being is that we can have stack effect. We can push that barometric relief damper open, and that's going to waste energy, right? When we don't need it. Secondary system that we're going to look at is an exhaust fan economizer. In this instance, what we're doing is basically placing an exhaust fan. It's usually, in some instances, it can be a bolt-on to a rooftop unit. In some instances, it's integral. The bigger you get, more likely you're going to have a fan that's built into the unit. Can be retrofitted to a unit with an exhaust fan module on the duct if you have a side return unit. Basically what you're doing, you're monitoring space pressure and you're trying to balance the exhaust with what your outside air is. Again, this is a lower static system. It's not going to be very effective when you have a high static duct return.
And that's a modulating fan, correct?
Yes. Yes, this is being, again, exhaust fan modulates from to full capacity when the unit is 100% outside air.
One thing to be cautious of too, when you're selecting these is sometimes there are multiple options based on, are you gonna have up to 25% outside air, or is it gonna be higher than that? Like, you have to select the right exhaust air economizer for the applications. They're not all just 100%.
Yeah, so it's not a one size fits all for each unit. You may have, if you have a 20-ton unit and your nominal airflow is 8,000 CFM, you're likely going to have 1 or 2 selections that you're able to take from that, or multiple selections that you're able to size that exhaust.
Yeah, your outside air is going to be brought in 100% through the unit, but you probably have ancillary exhaust, like Ken said, in the space. So you may have a couple 100,000 CFM, depending on your size unit, that you don't need to return back through that exhaust fan.
Thanks, guys. Similarly, return fan, this is typically in a higher tonnage system. You're going to, there's a slight difference here in that the return is going to be integral to the unit, not directly on the exterior of the unit where we're just pulling full, or we're just projecting. This can cycle back into, with this return damper, can cycle back into the system. This is basically sized to the static pressure of your return ductwork. So if you have a multi-story building you have 2.5 inches of static in a system that's probably a little bit high, 1.5 inches. You are going to want to have that information when you're selecting your return fan. Again, just kind of a summarization of what we're seeing here, advantages and disadvantages. Obviously, as you go down, the cost increases. That's the biggest take back when we're trying to be not cognizant of budget. Barometric relief is going to be small systems, exhaust fan. Your pressure drop is not going to be as high. You're not going to be able to overcome as much pressure drop with an exhaust fan. And the return fan is going to have a higher operational cost. And it's also going to, because you're going to have higher fan horsepower, because you're typically dealing with a larger volume at a higher static. So let's get into some of the system options that we have for controls. And, just here, basically what we're going to qualify, low pressure, we're going to consider this bottom part, and then everything else up here. We're really not going to be in high pressure systems when we're dealing with a rooftop unit, but we will see some medium pressure applications when we're talking about VAV units. So we're just going to dive in here. Some of the things to consider when you're looking at a system, if we're talking about a smaller tonnage system, but we still want some type of control for individual space, we're going to be able to use zone dampers on a low pressure system, pressure dependent, obviously in that type of scenario. So you're going to need to make sure you understand your static requirements of your supply side when you're looking at a low pressure system. There are some trade-offs that you get with a low pressure system. You're going to have lesser level of humidity control, but it is going to be very cost effective for looking at individual zone control. So how do we achieve zone control in a low pressure duct system? Tempmaster has their Verisys system. We have Zone X damper systems. We have Train. What's Train's proprietary? Trace? No. Veritrack. So these all are similar. You can universally kind of talk about them the same way. Essentially, if you have multiple units in a system, we're talking about having a smart building hub, which kind of ties the whole system together. Each rooftop is going to require a zone coordinator. And then each piece of equipment you have is going to have an equipment controller, whether it's a zone damper, whether it's a ancillary piece of equipment that you're controlling with it. You'll see Verisys has some very third-party oriented applications that we can tie into our system. And then you're going to have individual zone sensors. You can have these both with humidity control or humidistats and also temperature.
The controls are.
So here's kind of a simple breakdown of what we would typically see for looking at a single zone application versus a multi-zone application. One thing to really note here is that all of the components for the most part are the same, except you add in a zone coordinator when you have multiple units. Here is where we can see the flexibility of being able to control inputs to other units, whether or not it's unit heater for supplemental heat, whether or not we have a fan coil unit for same purpose, unit vents, and obviously other RTUs. Here you can see this is going to be the same whether or not we do VAV system or a zone damper system. You can control up to 32 zones per zone coordinator. So these are pretty large systems that we can build. Typically when I'm seeing these, we're talking about 12.5 tons and under. We're looking at smaller systems, maybe 10 to 15 zone dampers in a system. Any comments from the group here?
The Verisys Smart Hub will allow you to remote in, see everything.
Yes. Yeah, so this is essentially your connection through BACnet to a head end if you have one on your building, or it can act as a somewhat of its own smart system. It's a smart controller.
So from a VAV controller perspective, what is is it compatible with a lot of different VAV controllers, or is it specific to the Verisys system?
So if you were going to, say you had a carrier system or a Tempmaster system, and you were going into a place that had price VAVs and somebody had put Siemens in there or something, you would probably have to change out the controllers for our third-party compatible controller in order to do that, in order to be able to talk back and forth with your zone
But the
coordinator.
VEC 100 is the terminal unit controller.
Yes.
Okay.
One of the things that we also offer, in a system like this, and actually we have it in our office here, are VAV ceiling diffusers, another low pressure system option. Smaller system, provides a level of control at the room. As the thermostat is set, basically we're going to, there's a damper on the VAV diffuser that's gonna vary the amount of air that's coming into that space. So the volume is what's changing, unfortunately, not the temperature of the airflow. So they are somewhat limited in what we can have here. Most of these work off of a polling system where if 5 people are calling for heat, 2 people want it cooler, the women win out in that scenario because they're usually the ones that want the heat on versus the men who want something a little bit cooler.
And that polling is what controls the rooftop.
Yes, that
Heating or
good
cooling.
point. The polling feeds back to the rooftop and says, we're gonna change over to heat or we're gonna change over to cooling.
And the actuation of the actual damper at each VAV ceiling diffuser sees the incoming temperature of that air, responds to what the room thermostat's calling for, heating or cooling, and will either squeeze off some of that air or allow more air through to satisfy that room.
Yes. So when we're looking at this, the goals and benefits of a VAV diffuser, you're gonna achieve comfort with individual temp control. All of these, a VAV diffuser is a very energy efficient system. All of these categories lead to low energy usage in a system. When we're talking about it, in comparison to using reheat or using another type of system to achieve individual zone control. Here's just a very small example of what this might look like. Again, we want to have a highly efficient, most of the energy requirements that we have with rooftop units now, we have a minimum SEER rating that we're at. So we're seeing that pretty standard. Excuse me. So here's our diffusers with the dampers on them. There is different actuators. We do have options. One is a mechanically actuated device and one is a spring activated device that responds to a wax system. That's like a wax actuator of some sort that opens and closes as the heat increases. So just looking through here, you can see, where our low energy comes down, where our turn down comes in. We're able to monitor supply air temperature through here, bring it back to the system with polling, understand what each of the zones need. And if we have an instance where this office is really warm and they want cooling, but these are cooler and they want heating, we're likely looking at a system here where we're gonna starve this of airflow. So there are limitations. The damper is gonna shut down in the heating zone here. It's not the greatest system, but it has its place, especially if you don't have great diversity in your loads across the space.
It works real well for retrofits where you can't get above the ceiling and put a full VAV system in. And it also works good for just off, 2 off zones where you have a problematic zone that gets for whatever reason, it's overcooling in summer and someone's colder, you can put that in there and allow it to squeeze some of the air down to a minimum flow and not go to zero, but still give them some air in the space.
Again, just a continuation of this going on, showing the all the components. One of the things that we do here when we're looking at these, we are typically sizing these VAV diffusers a little bit larger. We want to keep the pressure drop lower. They work better at a low pressure. You think about it, high pressure is in a diffuser with a damper. You really have to shut that thing down to get any turn down. So you're going to cause noise and potentially just not have a very comfortable space. So we tend to oversize these a little bit. High pressure systems, some considerations that we're looking at. Obviously, the cost of high pressure ductwork when you're building a system is going to be more than it would be for a low pressure system. One of the advantages of using a low pressure system is the cost savings you can have with your ductwork. You can use cool duct on a low pressure system. If anybody knows what cool duct is. One of the other things you have to consider is your supply fan. Typically, we're looking at requiring a high static drive or even going into a plenum style fan. That is typical that you'll see in a larger rooftop system. Again, as we were talking about the economizers before, we're looking at having a return fan or an exhaust system. Typically not even an exhaust system, we're probably looking at a return fan here. It is going to be a pressure independent system. But there is flexibility with obviously being able to use the VAV to provide reheat and greater comfort and flexibility in individual spaces. So that's, I do want to preface that this isn't a system design course, it's a rooftop, so I'm just kind of going through some of the basics here. Further control strategies that tie into some of those systems and what we're going to do to tell the rooftop what to do. A lot of times we'll see variable speed on the supply, and the temperature in the space is going to dictate what the speed on that fan is going to be. So we're going to have a constant stage of cooling, and we're going to ramp that fan up and down in order to achieve space temperature requirements.
Generally, if you've got a VFD, you've got, you get a little bit more staging on your cooling as well.
Yes.
It kind of goes hand in hand.
Yes. What we call this from a Tempmaster perspective is IntelliSpeed, where we marry the speed of the fan to the stages of cooling. We're looking at discharge air control. Typically in a system like this, we'll have a discharge air temperature sensor in the system that will do that. Obviously with this, there may be a requirement for bypass in a system of this nature. Again, just expounding on that a little bit. You know, this allows the supply fan speed to be varied. It is an effective means of being able to reduce energy costs just from the fan usage, rather than having, you know, a single stage, single speed unit where we're just knocking that fan on and off at full horsepower. Occupancy control is another control strategy. Obviously, we want to have night setback on units when we can. We have in our system here, we definitely take advantage of that. We don't want, you know, most of this is accomplished through thermostats these days. Everything is pretty simple. Again, going back to what we were talking about with Verisys, zone control or control off of the return temp. That will modulate. If your return temp is starting to creep up, likely you're going to have a system that's going to engage your cooling, and you're going to read that off of your zone or return temperature. Again, this couples with, this is just a more complex setback type system, more data points coming into the system as we get more complicated. And then obviously Adding on to that is having digital control of a motorized damper on your air side economizer. To be able to take advantage of that, whether it's single enthalpy control, dual enthalpy control, we want to make sure that we're having precise control of the air that's discharging into the space, as well as the air that we're bringing into the building.
You mentioned the dry bulb and enthalpy control. What's the difference between the two?
The
Dry bulb, when would I use dry bulb? When would I use that?
when we're not concerned about humidity. I mean, that's this,
Yeah, no, I was just saying, I mean, I know dry bulb looks at just the
Just-
dry bulb
yes,
temperatures
yes.
outside and doesn't do any comparison of anything. Looks at outside air dry bulb, if we set it at 55 degrees, it's gonna go to free cooling at 55.
If you've got a cooler, humid day and you just have a dry bulb economizer, you're gonna fill your building full of
Humid air.
humid air.
yes.
Yep, so single enthalpy is gonna look at the enthalpy outside.
Yeah, single enthalpy will just be on an outdoor air sensor essentially. If we have dual enthalpy, then we're also talking about return air.
And we'll look at the comparison between the two and determine whether or not it's advantageous to do economizer.
Yes.
What the set point is.
Right.
Set up your economizer.
Also, sometimes we'll see demand controlled ventilation. We're putting a CO2 sensor in there. You know, this is a good way to minimize the amount of outside air that you're bringing in from an efficiency standpoint. Obviously, this is really important in high occupancy spaces. Whether or not you have a room like this that's got 20 people in it currently, we want to make sure that we're providing enough fresh air for comfort. And then typically everything's coming back, whether we're looking at our Verisys system, a VAV system, we're looking at network thermostats. Very significant part of what we offer as far as bringing everything back to a central location. We need communication through our thermostats in order to have high levels of control. And then coupled on top of that, and for clarity, these aren't individual strategies. These are all components of a larger strategy, and it's pick and choose what you need. Dehumidification control is obviously something that's highly configurable based on the options that we looked at before. Obviously, we need zone humidity, outdoor air, return humidity. All of those components are going to be necessary to have strong dehumidification control. So I'm gonna let us break for about 5 minutes so people can kind of reset. We are going to then kind of dive into our accessories and options and really look at what the difference between the different levels of RTUs that we have. So we'll come back at what time? 10:55 now. We'll come back at 11 and we'll continue. Welcome back. We are going to spend some time now looking at what it looks like to select a rooftop unit, whether it's a very simple unit or more complex. A lot of accessories build on each other for a system, but all of the things we discussed, you'll see as selectable and configurable when we get into our program. So Sienna's gonna dive into our selection software here. Good. All right, so can you go to project details here? Yep. Sorry, that was the wrong one. So go to this one. Yeah, just start over. This is the wonderful JCI software we deal with every day. That is the project. And we're gonna start out with what we call our core unit. Go down, we are looking at the this one here. Yeah, edit product. So one of the things that everybody's asking about right now is what impact does the refrigeration change have on the equipment? Right now, what we're seeing, a lot of people are scrambling to still put in R410A. Fortunately, most manufacturers have stopped building R410A units in, I think the deadline for construction of new units is the end of this calendar year. At that point, you'll still be able to install them, but you can no longer order one configurable new.
Yeah, they're still building them. It's just they had to cut orders off,
Yes.
so they don't flow into 2025.
Yes. So you'll see here from a system, all of our units are now 454B. So as we're going through, this is our basic core unit here. This is a 6-ton unit. You can see we obviously can go through some different efficiencies. We're typically going to be doing high efficiency. Gas heat is standard in in Wisconsin typically. Every once in a while, you'll see an electric heat option. If you look at the cooling capacity, this will start to clue you in on what's available. And you'll see here, this is our only unit in the core product line that is available with 2-stage cooling. So we're gonna have 3 2-ton compressors in there. And that's where I think the 10-ton is as well. Can you click on that once? And over here, we can see, it is 2-stage cooling. So we're gonna have 2 5-ton compressors on that unit.
Yeah, and some of that, actually, you can't get IntelliSpeed speed on this series, can you?
No.
Okay, because that will, well, actually, it says over on the right-hand side, VFD
Oh,
and
yeah, all of our units are going
probably
to have
because
Intel speed.
picked a high efficiency, potentially.
If you select the KX or.
Get a KX, then I think that changes.
So you'll see here, one of the things that's in our standard, we do have to define what static we're looking at. If we're looking at anything over an inch, we're typically going into a high static drive. Our core model utilizes a belt drive blower still. That is something that is being phased out over time and will be pretty soon direct drive blowers, pretty common across the industry with what's happening everywhere. So if we go down, you'll see coil options. They do offer the electro-fin plating for coil. Typically, we're not seeing that in our climate. That's something you're typically going to see in a saltwater adjacent area in order to protect that coil. We do have some availability with side return on these units. We can look at our different heat options. Typically, we're looking at low heat, high heat, medium heat, and then our heat exchanger construction. Voltage is something. If we go down into options now, you'll see here, we do have an option to be able to put reheat on this. It is not standard. That's something that obviously is going to add some cost. We do have our economizer that we're going to do here. In this case, we're going to select, if we did an enthalpy economizer, I believe it gives us another.
I think it's in the accessory screen.
Yes, under the accessory screen, it gives us what we're looking at there. Cabinet upgrades, simple. Right here, refrigeration detection system. So I'm gonna wait to describe that in more detail on the next unit that we're gonna look at, because it's going to, I wanna dive into the performance a little bit more on a more configurable unit. So you can go down even further.
That's specific to the refrigeration chain.
Yes, that refrigeration detector is specific to the refrigeration change. That is something that's required, not required, but it is.
May or may not.
It may or may not be required with our 454B. Again, you can see here, this is our Norman Mod shop. This is where all add-ons that are not custom or that are not standard modifications can be made. Again, this is where you'll see we can have a factory installed rail wall valve, You get a shaft grounding ring on a VFD, double wall. You know, if we are really concerned about the energy losses through a unit, we do have double wall insulation. If we're in a food grade situation too, or in food, maybe not full wash down, but wiped down, we may be able to utilize that. So if you go to the accessories tab, Sienna. You can see here, obviously, when you go concentrics diffusers, typically that's you know, something that's, if we're doing a concentric diffuser, we are able to ship it with here. Typically wouldn't, it would be shipped from a third party. You look at the controls tab. Here's where we get into supply and return. One thing I do want to stress to the engineers out there is clarity of what is required, especially when we have multiple trades in working together on a job, whether it's a controls contractor or electrician. If there is a supplemental smoke detection system in the building, we do not want to provide the smoke detector. Typically, it's not going to talk with the system, and we want to make sure that the system works. So defining who has that responsibility is a great pleasure for us to see, so we don't have to guess. A lot of these sensors are things that we talked about with regards to our control strategies. A lot of them are the same, they're just small modifications on the others. This is not, all these temperature sensors are not thermostats. These are just zone temp sensors. So don't be confused about that. We will see that there. Curbs, obviously, we have standard curbs here. Most often when we're dealing with the contractors, we are trying to purchase these elsewhere in order to get them to you ahead of time, because rarely does a rooftop unit, do they want it showing up at the same time a curb is there. Electrical. Phase monitor kit. Dave, please enlighten us on phase monitors, please.
If you have a 3-phase unit, phase monitor kit is just a device in line that will prevent the unit from being switched phase differently. So you don't have to worry about flipping the legs, it'll automatically take care of it. So the fact of bumping the motor, verifying rotation, it's all done through the phase monitor kit. You can see the price, pretty inexpensive. You can burn through a little bit of labor on the job site just trying to flip it one way or the other. So on large units, it comes standard. On a lot of our 25 pound and above, that phase monitor kit will come standard on some of those. So it's a time saver in the field, but when you're getting down and dirty in pricing, if there's other competitors that don't have it, it's something we won't include.
Thank you. So we go down to fresh air. Here is where you'll see some more sensors. Again, these are all field installed components. Anything in our accessories tab is not something that comes with the unit. It ships with the unit, but it is something that needs to be installed by somebody else. So whether or not, obviously with dual enthalpy kit, you're probably putting humidity sensor in the duct return. It's not going to be integral to the unit. We do have add-ons for most units with powered exhaust. So that is one thing to note here. Non-electrical, you're going to be looking at your flue extension kit in case you have two rooftops right next to each other. You don't want the gas discharge or the gas heat discharge right next to the intake of your secondary unit. Burglar bars, pretty self-explanatory. Hail guards again. These are the things that we're looking at. Typically, on a new construction job, we're not going to be looking at many of these things because we're taking that into account. Yeah, and then here's our thermostats. We can get you basically anything you need is what this shows. So let's go to our performance tab really quick. Click on use mixed air. This is our up here. This will give you your nominal performance for a unit, assuming that we're taking In this point, 25% outside air. We press rate, it'll show you all the information you need. You can scroll down. It does give you, obviously, we have to set our discharge and entering air conditions. That's something that we just have preset.
So if an engineer has a good schedule put together where they have return air temp coming in, they have a desired mixer temp or a percent of outside air or CFM of outside air, we can plug in all of those parameters and it'll give you the exact discharge MBH of that unit in this upper right hand portion above the supply fan. So there's your gas, tells you what your unit leaving temperature is. And if you scroll up for the cooling side, one thing to notice is the unit leaving temp of 59.7 down below. The unit leaving temp of 59.7, everyone's gonna look at that and go, how come that's a little bit higher than my evap coil leaving temp of 57.9? That's because you got some pickup temps coming across that fan and motor in the airstream of the unit. So you always wanna look at that unit leaving temp. That's the actual supplier temp in your main duct.
And we do have expanded sound data if we need it for units, but this gives us an idea of how loud a unit is going to be. Just scroll down a little bit, see if there's anything. So this also gives us what our operating horsepower is and our electrical information. So all important information when we're looking, and system charge. So, all right, let's go on to our next unit and see, expand this a little bit. So go to save product. The AJ. So this is a tier up on our unit tier. You can see slightly different. We have a little bit more options with filters. Here, we can go up to MERV 13. I believe the other one only had MERV 8. We are now offering two-stage heat in this unit versus single stage. So just little bits that add a little bit more configuration. Scroll down. Again, here, now you'll see also more options with our VFD system. So here's where if we're looking at a zone system, we're going to look at VFD with bypass, IntelliSpeed. We can then go into our system further down with our controls. We'll get to that. We also, this here shows barometric relief, economizer with power exhaust, or motorized damper. What's important here is that these are factory installed versus the power exhaust on the previous unit, which would have to be field installed. So as a contractor, if you're looking at this, do you want your field guys worrying about a damper, or do you want this as a factory installed option? Might be something that you consider when you're talking to your airflow rep about what your needs are for a project. Convenience outlets, disconnect switches, phase monitor again. Now we have some more information with the dirty filter switch, with the enhanced filtration options. Again, here, this is where we would select, if you do Verisys changeover bypass, this is going to allow us to then go in and start to select a zone damper system. So why don't we click on that just so we can go over and show you the options there, things and components that you might need for a zone system. Again, reheat, let's put reheat on this unit. It does have hot gas bypass as an option, but we're going to use hot gas reheat for our humidification needs. We're going to keep refrigerant detection system on currently, but we are going to come back to that as we go through the unit selection. So let's go to the accessories tab. And don't worry about that. Let's go to controls. And again, similarly, this is the start of what we see with our controls options. These are our sensors. We'll see these also in another tab. So click out of this first. Let's go to fresh air. Let's select our economizer. So we're going to, these would be field installed economizers. So we've already selected. What did we select? Did we select one?
No.
We did not. So go back. Sorry.
I don't think we picked the count.
But let's select. Yeah, let's select just barometric relief on this unit again. And go back to the accessories tab. All right, so now let's select the dual enthalpy kit. Because we want to make sure we have dual enthalpy to compare the two. And then let's go to Verisys bypass damper controls. So you now can go in and whether you have I think this is I don't know what tonnage unit it is. Say we have 5 zone dampers included in this. We'll need to select the damper and then controller for each. So we would select, say, 5 10-inch zone dampers. Right, you would select 5. I think we have to do it outside of this. That's fine. Select it. Yeah, so scroll down. I actually scroll back up. You'll notice here in this tab, all the way up. So in some instances, we're going to want a differential or duct static pressure probe. If we're doing a bypass system, we're going to want that. So I'll just click on that. And then we go to the next screen or next tab versus network. And this is where we see we're going to want our Spark building hub with a power supply. And you can see this here will have our input output controllers as well. And note these prices are not what you would be paying for one of these. These are our list prices. We do get discounts on them. So let's select that as well. And then we'll go to sensors. And in this instance, let's just say we're going to control off of a zone temp sensor only. We're going to allow the unit to take care of the enthalpy differential and decide when it's going to have. It's going to allow economizer. All right, so then we'll go down. We'll go down to the zone coordinator. And you'll see, we'll take this one here. We'll need that. We also have power transformers. All of these controllers are going to be powered by 24 volt. So we're going to want a control transformer typically under the zone power. But let's go to damper controls first. These are the zone damper controllers. Select this. Another one we're going to use for the bypass damper. And here you would see here are all your transformers that you can have. So in this system, we would just need this small transformer. If we have 120 volt, if we have 480, 270, 240, we would need that. Or if we had a larger system, we would upsize to that. So that's how we would build a Verisys system. Obviously, we have to change the quantities on some of these. That will happen on a different screen. We're not going to bore you with that. But if you go back up to the very top of the screen and we go to performance, here we're going to run our performance here. So here it's telling us that we are not able to satisfy the system static of these dampers and the unit itself. So we need to move to a high static drive. So click yes. And that will automatically change. That is a field install that you have to do in order to do that. So if we go to the top again now we're gonna show the RDS calculator. So right here, we have a 10-ton unit. Maybe this is serving conference room, 5, there are 4 other offices, so we have 5 zones we're controlling. This calculator here allows us to determine whether or not we need a refrigerant detection system. I don't know the formula. I don't know what the charge is that per square feet. This program allows it, so if you're wondering, as a designer, whether or not you need to have, if you have multiple zones, we would have to define multiple zones. But let's say we're in a single zone. The room is, let's say, 50 by 80. And we're in a training room here. Let's say that the diffuser height's at 16 feet. It's going to calculate, and it's going to tell us we do not need refrigerant detection here. So although the refrigerant is more flammable and there is a concern in the space that we see, we're going to remove that refrigerant detection system from our quote. Now, as a specifying engineer, you may want to ensure that that's there. Know that it comes with a cost on higher tonnage units. It's going to be not as significant as you might think, but it does make a difference.
So do a converse one like we did yesterday, 5 foot by 5 foot, just to show that it.
Oh, yeah, so if we said, okay, we're serving a room that's 10 foot by 5 feet with a short height, you'll see that this will tell us. Yeah. This will just tell us that it is required, so.
So it's using the pounds of refrigerant that could be dispersed into the volume of the space to make sure to correlate that back to the parts per million or whatever the concentration level of the refrigerant can be in the zone.
Yes.
So you don't have to remember what that number is. You know, most people probably don't even know what that number is right now. This will actually tell us. So when you call in and ask for someone to run it, they can run it for you and tell you whether or not it's required.
Yes.
And if you have multiple units, if you have 5, 6, 7 units on a big wide open warehouse
We're in a
space,
warehouse.
you have to look at the whole system as a whole with all of it. So you would divide your square footage out by number of units you have, and calculate it that way.
Yes.
So on a multi-zone, let's do we were pricing this up as like five
Yeah.
zones, right? So
I believe it gives each individual room.
So click on total area of the zones. Yeah, each zone individually.
Yeah, so you're gonna have to add, so you have the ability to add each individual row in order to calculate it out. It's a lot of work. Not too bad, but we can do it. So, okay, let's move on to our next class of units where we can see even more options. So just save product here. All right, now let's go into this, yes. So this is our choice unit. You can see here, our tonnages have increased. This is good from 15 to 27 and a half. Now modulated, if we're gonna do gas reheat, it's going to be modulating. We're gonna have more stages of cooling. We're going to have, in some instances, 2-stage compressors, 4-stage compressors. We'll see as we change things. So let's select a 20-ton unit. I bet it gets us four stages of cooling here. It doesn't say. Oh, it's still 2-stage. But you'll notice here, like we were talking, it has control of the VFD based on stages of cooling. So because this is a single zone VAV currently, the fan will work to stage of cooling that's required. So your air volume will vary throughout. Let's select modulating hot gas reheat. Now here you can see, again, even a little bit more, we can do modulating heat with stainless steel heat exchanger. Again, similarly, the filters here. Now we have some more configuration here. We can do horizontal side or horizontal end. Be wary though that work with your rep when you're doing this. If you need horizontal returns, it does remove some of the options that you have available as you're going through that. So you can select a unit, but then say, oh, I want it horizontal side. You're gonna have to work with your rep in order to make sure that you can get all of the bells and whistles that you want. So let's select natural gas stage. Actually, sorry, modulating heat. And then it'll ask you, it's okay, we have to select high heat. Now we go down to options. Now what you'll see is if you go VFD VAV here, it gives you a 4-stage option on this VAV or on this VFD. So that's where you're going to understand how that drive is going to operate with the stages of cooling. So go back up and let's just do IntelliSpeed. And let's select an economizer. Here now you can have your enthalpy sensors factory installed, which is good. So let's do dual enthalpy factory installed. Now you'll see we also have the option that we put a CO2 sensor in there for demand controlled ventilation. So let's say we're going to do demand controlled ventilation and we're going to do powered exhaust. We're going to say Verisys single zone. Again, similar things here. Now, when we get in here, we do have the option for a stainless steel drain pan, which we didn't before. There was just a standard, just little things that they keep adding on. I was on the right side. So, again, all of these are now factory installable where they weren't prior. Especially when we get into like the hail guards, that was an option, an accessory that would have been field installed before, standard cabinet versus hinged, all of that stuff. Again, here you'll notice the refrigeration detection system. Let's go. Again, similarly, we do have these similar, one of the things we do see is dual point power that's available now. Airflow monitoring is another option that we get with this unit. So if we want to feedback and say, we want to know what our outside air coming in exactly is, we have the opportunity to do that factory installed at this point.
And those Norman mod shops, they add a couple of weeks, but they're actually done at the factory and leave the factory as
Yes.
a factory.
The mod shop is across the street from the production line. They have to ship it over there. It's actually sent over there and then shipped out to the customer from there.
Yep.
Compressor sound blanket, another thing in case you have a noise in the area issue. Let's go to accessories tab. Again, similarly, you're going to see the same things, but when we go into some of these controls, go to controls, you'll see a lot of these similar. What was that, Dave?
But you get the condensate overflow switch as an option.
Yes, yeah, condensate overflow switch is now an option. That's something that's been added. You can have an LCD display on your temp sensor for your economizer. Map gateway access, network displays, all of this stuff is just additional controls options that we're gonna have. Keep going down, we're good. Let's get to electrical, see if there's anything additional on this. Again, just convenience outlets, fresh air, probably the similar options. We already have our things all set for our economizer, so we don't need to worry about that. And then we'll go into the Verisys network again. We don't need to go into there, but again, the same types of things that we were seeing before. Here you'll see that we do have these, if it's zero, they no longer exist, but we do have other things that we can have. We do have wireless capability with our Versus system. We do need to define that that's needed, though it's not a standard.
And this may look a little bit more complicated than it really is, but what the customer or the engineer will see will be a lot more simplified than this. This is no different than any else's, the carrier eye view or the tracker or tracer from Train.
Yes. So let's go back to our estimate. This back arrow. And we're gonna add our premier line, which is our large tonnage units. Yes. So here, we're gonna go to the 25 to 150 Tempmaster. And this is where you start to see, obviously, the size of the units is a lot bigger. Thank you, Dave. We're gonna just start and build a unit from the ground up. One thing that, and it was actually prevalent in our choice units as well. What we're seeing is this 65 KA rating for our disconnects now. This should be, from a design perspective, something that we are aware of ahead of time if it's needed. It is a costly field fix if you do not have this included. Yes, we can get a factory or we can get a field installed disconnect that meets that rating, but it changes the wiring of our unit. So knowing that we want to have that higher rating is essential. So let's select that. Say there is that requirement. Yeah, let's go down to cooling. Here you can see our nominal cooling capacities. There's a pretty wide range. Obviously, there's gaps in between there to some end as we increase. But let's select a 60-ton unit. Standard capacity is fine. Again, over here, for this unit, it's going to default unless we really tell it that we don't need it. This is an expensive add for a 60-ton unit because you have to have a sensor. You have to have multiple sensors on the unit. It is not just a $500 piece at this point. So let's go down. Again, heating, here's where you'll see we have some additional options now. We can do a steam coil or a hot water coil, which is something that we might see on a larger unit when you're putting in a healthcare facility. You might have a boiler plant. Let's stay with modulating gas. Again, you'll see it over here. These aren't populated because we haven't selected hot water or steam, but you can have factory installed valves on that. Going down. Economizer. It's more complex at this stage. Typically, if we're doing dual enthalpy outside airflow measurement, we're probably going to want one on a 60-ton unit if we're serving critical spaces. Again, CO2 sensors. And then we're going to where our return and exhaust fan are. This goes back to where we were talking about the economizer and what we want to do with our return and exhaust. So in this instance, we're going to say we're going to have this on a return fan with the VFD. Notice all of the different options that we have now. Okay, we can even go to a TFC motor. You can put those fans on isolators, defaults to 1 inch, you can go to 2 inch if it's required. Shaft grounding rings, belt guards, all of that. I believe this is not applicable because I believe we're a direct drive fan. So let's put return airflow measurement. And let's keep going down. Again, here, further filtration, right? We can do draw through filters. We can also do vinyl filters on a unit. So we can do a draw through filter of MERV 8 on this. So let's do angled 2 inch MERV 8. Let's put a filter gauge on there with a transducer. And then let's go down to our side supply fan. So here, again, you'll see in this instance, we're going to have 2 plenum fans. You can see we have 2 motors. We have a single VFD handling those 2. You can have one individually for that. But these are, again, expanded options that we have with these units. We have supply airflow measurement here. I'm assuming it's defaulted because we picked it on the return. And then here, again, more options, hot gas reheat coil that we're gonna put on there. Again, the E code, we don't typically see in our climate. Going to have ultraviolet lights for some pathogen removal for a unit like this. So highly configurable is what we're looking at when we get into this series. I think that's the bottom of it, is it? Let's put an overflow switch on there. The drain pan. And then when we look at our return cabinet, we're looking at, we can configure where we want it coming in. A lot of times with these units, they're so big, it's not necessarily going to be a simple bottom return because you have to match up with what's coming out of the building. The unit size may not match that. We may want to include an air blender in order to get a good mix on return and outside air prior to going through. And then we go down to our discharge cabinet, and here's you'll see where we can have a final filter, even with HEPAs. Now, we won't supply the HEPAs through JCI, but we can help you out with that. Similarly with sound attenuators, we would probably do that through a different vendor. So let's just keep that as it is. And then finally here, there are some additional control options that we can do. Low ambient, you can put in here on some units. You can have a unit control with a touch screen. All of these things are things. The other thing that you can add now is you can add energy recovery to these units, which every other unit we have, it would be a bolt-on module, except maybe the choice, I believe, has an option for it. But that's what we're looking at. So let's just leave that as is and go to accessories. Are there any questions? Yeah.
Question from anonymous, when the unit ships with RDS, where is its sensor and where does that system?
I believe the sensor is on the
Condenser coil.
evaporator coil.
Evaporator coil?
In the unit, I
Oh,
believe, it's
yeah,
in the unit,
that
it's,
makes sense.
it's in the airstream, so it's measuring a leak of R 454B that would be put into the building itself.
And if it senses it, it's going back to the smart controller and shutting the unit down.
Correct.
So, I'm not gonna get into putting, let's just go through the accessories quick as we're wrapping up here. Again, curbs, obviously. One of the things that, a lot of times on a big unit like this, we're gonna want seismic curbs. We work with this, third-party curb vendor that'll build seismic curbs for us, or vibration isolation curbs. And they have it for all makes and models of every unit. Also, if we need a curb adapter, you have an existing curb, probably not for a unit of this size, but for a smaller unit, we're able to accommodate that as well. Again, very similar with what we're doing. In this instance, they're offering, you could just have a pedestal roof curb kit for the condenser portion only, and then a roof curb, you could put both of those together. Let's go down. Wireless, most of the controls are already built in for a unit like this. So the selections are quite a bit easier. Keep going down.
What was the smallest tonnage on this series?
25.
25.
So you can see they're limited because everything's already basically built into to the controls here. So we go up. Again, we do have the option here. One thing we would highly suggest is that with these units, we need to quote factory startup with them. We have a factory trained technician at Airflow that has completed the training. We've done a couple of units. So we do have factory assistance available, but as things go on, we'll be able to handle that in-house. So with that, are there any questions here in the room? about selections, about what is available, anything that you guys have seen that out in the ether that people have seen with different options that are available with other manufacturers that we can bring back to Tempmaster and give them some feedback on would be highly appreciated. Like I said, didn't want to make this proprietary, but this is a good example of when you're moving through a selection, what kind of different requirements we're looking for, and what information we as vendors are looking for, and what you guys can specify. So give it a minute for any questions, and then we'll.
There's one that says I have an owner that wants to back up an RTU for heating only. Just wants the fan, a controller, and gas heat. Does not want DX cooling, so it can put less load on the generator. Is that easily an available option? So I think what they're asking for is they have an existing RTU maybe, and they wanna decouple the DX power from everything else required to run the heat side of it. I don't know that you can do that because of the listing and label on the rooftop unit. We may be able to get it with two different power sources, but I don't know where that split is for two different power sources on a big RTU.
Yeah.
I think if you're looking to do something like that, you're probably doing it as a decoupled type system and not powering your condensing unit. So you're doing a split system.
If whoever asked that question wants to contact myself or Dave or Tom in our office, we can probably get a little more information and help out with that. But I don't have an answer off the top of my head on that one. Any other questions?
That's it.
All right, well, thank you. I hope everybody learned a little bit something about how configurable units are, and thank you for attending.